Well, hello guys and girls. Tonight we are going to talk about graphing polynomials and how to find what a polynomial looks like without using a graphing calculator. And I have put a file called Behavior at Roots underneath your assignments on Edline, so you want to go grab that because this has a lot, I think 10 examples of what we're going to talk about today. So there's really two important things I want you to get today. And those things are end behavior and behavior at roots. So let's go write that down. Let me see here. All right, so we want to get end behavior, and we also want to get behavior at roots. Okay, because what we're going to do is we're going to graph without a graphing calculator, and we're going to be very, very specific on what the graphing calculator would show us if we were able to put it in y equals. We're going to be very, this is pretty technical, but it's going to be also very accurate, and we can figure everything out just by looking at the leading coefficient and looking at roots and looking at our factored form. So let's get started. Let's do end behavior. End behavior is what happens as, this is called the limit as x approaches infinity, or a limit, LIM, as x approaches negative infinity. If we zoom way out to the left and way out to the right, what does our graph look like? Now, polynomials, if it is a polynomial, exist everywhere. On the entire x-axis, there's always a dot. There's no gaps, there's no holes, there's no sharp turns. It's a little smooth, continuous graph. So it exists everywhere, and so that means pretty much it's either going straight up or straight down at the end. And so I'm going to show you how to figure that out first of all. So let's take a look at our leading coefficient, and also the degree. This is what you need to be able to figure out. Leading coefficient and the degree. So let's start with an example. If you have a polynomial that, let's just say, the 2x to the 7th. Our leading coefficient, I'm going to do LC, is positive, and our degree is odd. In this case, the graph goes down to the left, and we're talking about zooming out, and then up to the right. So as we approach negative infinity, the graph goes straight down. As you approach positive infinity, the graph goes straight up. Let's do another example. How about negative 2x to the 9th? Here I have leading coefficient is negative, and my degree is odd. This is going to flippy-floppy that. That's going to go up to the left and down to the right. Now keep in mind, I'm not talking about what happens in between here. This is as x approaches negative infinity, the graph goes up. As it approaches positive infinity, the graph goes down. Okay, another example would be like 7x to the 4th. Here we have leading coefficient positive, and our degree is even. This is going to go up to the left and up to the right. Sort of like your quadratic. Anything that has an even power and a leading coefficient positive, it will look like that in the end. And the last example we need to look at is like negative 9x to the 6th. This has a leading coefficient negative. The degree is even. So our end behavior is going to go down to the left and down to the right. So that's one thing you need to know. What does the graph look like in the big picture if you zoom out? The next thing we're going to do is the behavior in the middle. What happens at the roots, or where the graph crosses the x-axis? We also call these zeros. And I'm going to give you several examples, and those examples come from that file that I wanted you guys to get. So let's go take a look at that, and I'm just going to talk you through this for a second. My first example on this file has a factored form of quadratic. It's factored so that we can figure out the roots. I've got a root at -1, I've got a root at 3, and a root at -5. And so those are the zeros. Of course, you factor it and you set it equal to 0, and that's how you find out where the graph crosses the x-axis. So over here I've got a root at -1, a root at 3, and a root at 5. Now let's take a look at what happens to the graph at those three places. At -1, the graph does not go through -1. It comes down to -1 and bounces back up. We're going to call this a tangent. The reason it does that is because the exponent on the root of -1 is even. Anytime you have an even exponent on a root, then the graph is going to display this tangent behavior. It's going to bounce off of the axis. At 3 and at -5, our exponent is just a 1. In that case, the graph just crosses through. So let's take a look at all of this. I have the highest powered term would be 2x to the fourth. Here's an x squared and then 2 more x's. That gives you an x to the fourth. The leading coefficient positive, the degree is even. So it goes up to the left and up to the right. And then it has to touch all these roots. Looking at the exponents on those roots will tell you how it touches it. Exponent is even, it comes down and just bounces off of it. The exponent is a 1, it just crosses straight through. And that tells you how the graph behaves in between. Well, let's do another example here. I've got a factored form, x minus 3 to the fourth, x plus 5 to the third, and x minus 2. Here my roots are 3, -5, and 2. My highest power term would be an x to the 8th because I'll have an x to the 4th and an x cubed and another x. That's an x to the 8th. That's an even. So this is also up to the left and up to the right. Alright, this first root of -5 happens out here at -5. And if your power on your root is an odd number bigger than 1, like a 3 or a 5 or a 7, what it's going to do is going to create a point of inflection. For now, we can just call that a wiggle. The graph is going to come through and wiggle. It doesn't just cross through, it wiggles. And then on the graph out here at 2, this root of 2, it just crosses through there because the exponent there is a 1. And then out at 4, I'm sorry, not at 4, but at 3, out here at 3, the graph is tangent because it's got an even factor on it. I'm sorry, an even degree. So it bounces up that way. All right, so there's 10 examples here, but I want to have you, I want you to watch me draw one. So let's come back here to our little notebook and give me a new page. All right, so I'm going to write down an example of one here. Let's have a little marker. Let's have x plus sorry about that, x plus 2 and x minus 2 squared. Well, my little air slate is being weird, but that does say x plus 2 and then x minus 2 squared. And so this is our function we want to graph. All right, let's take a look at our end behavior. If we multiplied all of this out, our first term would be x to the third, because this factor x minus 2 squared gives us an x squared times an x, we get an x to the third, and the coefficients on the x's are 1s, so this would be a 1x to the third. Leading coefficient positive, degree is odd. So if you look back at the beginning, this is going to go down to the left and up to the right. But we also have zeros. When x plus 2 equals 0 and when x minus 2 equals 0, this tells us our roots, or our zeros, or where the graph crosses the x-axis. So let's see how we can do here. Draw our little axis. It's a little slanted, I apologize. I'm going to have a root at 2. I'm going to have a root at -2. So my graph only touches the x-axis at those two places. It's got to go down to the left. So a little smooth curve down to the left. It's got to go up to the right. And let's talk about what happens in between there. Since the root of -2 came from a factor of x plus 2 and there was an exponent of 1, the graph just crosses through. Doesn't do anything special. Crosses through, and then it comes over here, and since the root that at 2 came from a factor that had an even number on it, an even exponent, that means it's going to exhibit that tangent behavior. So the graph comes down and bounces off the x-axis and goes back up. Let's see another one. Let's do x to the fourth times x minus 2 cubed times x plus 1 squared. This is the factored form. You'll have to do your own factoring tomorrow. But this is going to give me an x to the 9th. I have an x to the fourth and then an x cubed and an x to the ninth. And all of the coefficients are 1s, so my leading coefficient is going to be 1. 1x to the ninth. Oh, horrible, but whatever, sorry. All right, this gives me a root of 0. This gives me a root of 2. And this gives me a root of -1. Let's see if we can graph this. -1. Leading coefficient positive. Odd power, we're going to go down to the left, go to your furthest left root and go down, and then up to the right, go to your furthest right root and go up. And let's see what happens between there. At -1, I had an even exponent on that factor that created that root of -1. That means it comes up and it bounces off and goes back down. Then it's going to do the same thing on the root of 0 because I've got I've got an even root, so it bounces again. And then here on the root that's created from x minus 2, it's going to come up and do this little wiggle. This is called a point of inflection. And there is that graph. Okay, I wanted to check our time there. Let's do one more example here. Okay, let's do, how about, I'm going to try and pull one from your homework here. How about 3, 4, 5, 6, an x cubed, an x cubed, and then an x plus 2, and then an x minus 3 squared. All right, so here's our function in factored form. Let's see what the roots are. The roots are 0, -2, and 3. And if we multiplied all this out, I'd get an x cubed, there's an x to the fourth, this would be an x to the sixth, and it would be a 1x to the sixth. 2 x's, 3, 4, 5, 6. So this is going to be up to the left and up to the right because my leading coefficient is positive and it's an even power. So let's do our roots. A root at 0, a root at -2, and a root out here at 3. Up to the left, up to the right because of our leading coefficient positive and the degree is even. And let's look at this root at -2. The exponent on that root was just a 1, so that means it just crosses through, no special behavior. At 0, however, this factor that created that root of 0 is an odd number bigger than 1, so we're going to have to show the little wiggle. So it's going to come up here and wiggle like that. And then the root at 3, that's an even number. That's going to come down here and it's going to bounce off the x-axis and be tangent. So there you go. This is what you're going to have to do tomorrow. You're going to have to factor. And again, go pull up that other sheet of paper, Behavior at Roots. This has 10 examples that shows you what I'm talking about. And hopefully you'll be able to get this done tomorrow. Anyway, I will see you tomorrow.